Hi, AP Chemistry. I thought I would take this e-learning opportunity to share with you a test analysis of the most missed questions and give you some feedback on the free response questions. Primarily, the most missed questions were 6, 12, and 17, and then the first three were your free response. So let's start there. Number one, which structure, B, C, or D, minimizes the formal charges for each atom in? Justify your choice. So basically, you had to go to B, C, and D and calculate the formal charge on each of the atoms. Now, on B, you only had to do two formal charge calculations because the two F's are the same and the two O's are the same. On C, you had to do three. The F's are the same, but you have two differently bonded oxygens. And then on D, you only had to do two. The F's are the same and the oxygens are the same. And when you got to D, you found the formal charge for everything there was 0. So the answer choice was D. Question part 2. A student proposes that the energy of the xenon to fluoride bond in the structure in B, let's go back and look at the picture B, the xenon to fluorine bond is equal to that of the xenon and fluorine bond in A. Well, in A, there are 4 xenon to fluorine bonds, and they're all single bonds. And in B, there are 2 xenon to fluorine bonds, and they're both single bonds. And the answer is you should agree with the student because they're both single bonds with the same 2 elements involved. And single bonds between the same elements should require the same amount of energy to break that bond. Now, we're going to go look at A real quick. I hate how they drew A. That's not how I would draw A, but this is what they gave you. I would draw A like this. So I would have xenon with its 8 electrons, and then I'm going to have this double bonded oxygen here, and then I'm going to have the fluorines. I'm going to have this domain split and do my fluorines, and this domain split and do my fluorines, and leave myself with the unshared pair. This makes it look like it's like a half split domain down there where the way they've done them. So I would have drawn mine a little bit differently, and I think that might have confused some folks. But going back to the question was, is it polar or not polar? And its electron geometry is octahedral because it had the 8 domains. And then its geometry is square pyramidal. You have 4 around the equator, 4 equatorials, and then 1 that had the double bonded oxygen on it, and then on the other polar bond you had the unshared pair. So immediately, hey, got an unshared pair, it's probably going to be polar. So those were, I think, 2 points apiece, and those were the most likely place people lost a point or two. In number 6, this was also a short answer. In compound Y, and we never did even look at W, I just cut it out of the picture. I should have just deleted it. And the carbon-to-carbon bonds, would they all be the same length in this cyclic structure right here? And we saw this as double, single. Carbon-carbon single and a carbon-carbon double, single, double, single, double. This is resonance, because it could alternate. These could be the double bonds and these be the single bonds. So that would be the resonance structure. How do we know? All the bonds are the same length because they're identical things bonding. And so I thought I put an answer there and it disappeared. But the answer is the bond would be the 1.5 would be the bond order. Something happened to my answer that I had right there, so I'll put it back in. The bond order is 1.5 as the single and double bonds resonate. The order of single is 1, the order of double is 2, and so each of those bonds would be a 1.5 order. Now, on to the multiple choice. The chloride of which of the following metals should have the greatest lattice energy? And they were all chlorides, and they were all group 1 elements. And so the smallest ion wins, and that would have been the lithium choice. And 17, that's the one the majority of the people missed. You said valence electrons only. That's not true. Yes, A Lewis structure of an atom does show only valence electrons, but this says molecular compounds. This shows shared pairs of electrons in bonds. That's the point of drawing your Lewis structure. And then we found the flaw in a two-dimensional Lewis structure, and we translate it to the three-dimensional molecular geometry that you learned about. But on the whole, everybody, it was great work. It was much higher scoring than last year, I'll say that. And it was a very consistent score. The high wasn't terribly high. The low wasn't terribly low. There was a bunch of scores that are the same scores. And I'll just tell you this, because of e-learning, I have just given you a summary and I'm giving you the curve. You are going to respond to a Google form that says, yes, I've gone back and looked at my test, and if I have questions, I'm going to put it in this form and ask Ms. Kavanaugh about it. And that's your e-learning assignment that will be due on who knows when those things are due, because you're supposed to get 5 days after you return to school. So whenever that is, that'll be the day that's your final chance to do that. Have a wonderful break. Don't forget, sit around and watch AP Classroom. That's your official assignment. Many of you said you wish you'd had more time. Merry Christmas. Here's your time. Before the power goes out and you lose your internet connection, go watch some Unit 3 AP Classroom. Bye-bye, everybody. Email me if you need me. There will be a class meeting. You'll learn about it later.